Pangaea is a training that has the objective to bring the astronauts on field and learn the principles of field geology. We are here in the Dolomites discussing now about sedimentary structures, discussing about different rock types. Of course, this cannot be done directly, but we need to give to them some basic knowledge about geology, and especially about geology of the Earth, because through the geology of the Earth we can understand the geology of other planets.
We do this course because we want to prepare our astronauts not just to explore other planets and to be geologists on other planets, but to prepare the exploration together with engineers and scientists to be able to be equal in discussing features, science, difficulties, logistics, safety. So we want to be able for them to be partners, equal partners, and to get to a different level. So to know geology and to become knowledgeable about Moon, Mars, asteroids at a level that geologists would appreciate. Francesco Sauro was the coordinator of this course, the designer of this course, and he has designed this course together with the science coordinator, Matteo Massironi from the University of Padova, who is the prime instructor of the course.
During this first part of the training here in the Dolomites, we had some practical exercises. The first one was about recognizing rocks on a riverbed. So we had a riverbed with a lot of different types of rocks coming from different sources in the river basin. And the astronauts had to recognize them. That means not to give to them a name, but just to recognize which could be the process that have formed them. And then, thanks to the geological map, to assign each one of these rocks to a specific area of the basin of the river. Second exercise was to go on a viewpoint on the Dolomites and describe with words, but also with a drawing, what we can see in terms of geological features. So a sedimentary sequence, strata, folds, and all what we can see, and then put all them together and try to interpret this environment, and so to try to understand what makes it.
We will hear from the astronauts how much they appreciated this course, but we already realized from the amount of questions they asked, from the interest, the motivation, from the interaction they had with the scientists, that they love to discover, for example, in a comet exercise, together with the scientists, they followed the process that the scientists have followed themselves.
And the third exercise was a field trip to a place, a canyon called the Blätterbach Canyon, and in this canyon it's really interesting to see sedimentary features. So it's one of the best places in Europe to see sedimentary features which are very similar to the Martian one. So they had to go through a sedimentary sequence from different kind of sandstones to actually organic rocks. And it was extremely interesting because in the same path they had the possibility really to reconstruct the history of these mountains and the environment that formed this kind of rocks and features. The prime instructor was Matteo Massironi, a professor from the University of Padova, who did a lot of work about planetary geology on Mars, on the Moon, and especially recently on the comet observed by the Rosetta mission.
The astronauts are really smart. They are very different one to each other, very, very well selected for the course, because each one has the right behavior for dealing with the field in a different way.
Harald Hiesinger, who is a professor from Münster, a very deep expert about the Moon.
I'm talking about the moon, how the moon developed, the origin of the moon, the geologic history of the moon. There's good evidence for volcanism, for example, so all the dark areas on the moon are formed by some volcanic material, basaltic material, and so I'm talking about how this happened. I also talk about impact processes because the moon is bombarded with impact craters, and so the physical process of impact formation, but also how we can use impact craters to date surfaces. I think it's also really important to go back to the moon because of the impact history, okay? Because it's the Earth-Moon system. So whatever happened to the moon also happened to Earth in its past. So understanding the moon will also tell us something about our own history. And so that's really important. In addition to that, we take the knowledge that we gained from the moon and we extrapolate it to other planets and asteroids to date those surfaces. So if we know some surface on Mars is, let's say, 3.5 billion years old, we only know that because we went to the moon, we collected samples and we did some crater counts there and combined those two pieces of information.
We had also Nicholas Mangold, who is working with the Curiosity rover mission on Mars. Anna Maria Fioretti, she's an expert about meteorites. Meteorites are really strange rocks, so it's really a specialization in this kind of fragments that gives us information about the solar system. And then, yes, of course, it was me as a geologist, field geologist, about sedimentary features, and Riccardo Pozzobon for the satellite images interpretation. He is a planetary geologist from the University of Padua.
They will be able also to discover new things in different kind of contests, very alien contests, even minor planetary bodies, like a comet, for example, in which recently we have understood a lot of new things in the Rosetta mission. And I think that after this training, the astronauts will be able to find things very similar to that one, new discoveries on other planetary surfaces. And I think this is really very exciting.
I think it's a very good idea to have this course because those will be the guys that eventually will go back to the moon, I would hope, you know. So the better we train them, the more we will get back.
When I go to the moon, and maybe, who knows, even to Mars, I hope to be able to make a good description of what I see. I hope to be able to make a good estimate of what, of where I am, of what samples to choose, and be able to transmit through my eyes and my words the science that is around me on the moon to the scientists on the Earth. That is a great responsibility. It's something that we learned during the Apollo missions more than 40 years ago, and that today we have to pick up again and use it again and evolve again so that the astronauts of the future will do even a better job, if possible, when it is our turn to go on a different celestial object.